Okay, let's unpack this. You, like all of us, probably juggle more digital information in a day than, I don't know, a small library used to hold emails, streaming, just online stuff.
Yeah, it's incredible.
But now imagine that, like, exponentially for a whole company. Businesses aren't just swimming in data, they're practically navigating this ocean of financial records, HR files, operational logs, sales figures. It's just vast.
Absolutely overwhelming sometimes.
And what's really fascinating now is how companies aren't just storing this data anymore, but actively bringing it all together. They're merging huge amounts of info from all over the place. So the big question for today's deep dive is this. As data gets merged more and more, especially for things like business intelligence and, critically for AI, how do we actually protect it?
Right.
How do we make sure only the right people or maybe even the right AI systems have exactly the access they need and, nothing else?
It's a huge challenge. And honestly, it's evolved so much. We've gone from these sort of siloed databases to these really complex AI environments, and keeping it secure is more critical than ever.
Yeah.
Traditionally, managing access often happened inside individual systems. But when you start blending information from everywhere in the company, the whole security picture just fundamentally shifts.
Okay.
So we're going to explore how we got here and look at the specific strategies, the kind of robust strategies companies are using now to protect this newly merged data, trying to keep security tight without, killing innovation or those crucial insights.
So let's maybe set a bit of a historical baseline first. If you think back to how we first handled enterprise data, it was almost like separate islands, wasn't it?
That's a good way to put it, yeah.
Financial data lived in one system, HR in another, operations way over here, sales somewhere else. If you needed access, you basically had to row your boat to that specific island.
You're absolutely right. You'd have a user or maybe an application making direct requests to these separate data systems. And the approval was pretty granular. You'd ask for access to just the financial data, for instance,
Okay.
and the control over that access. It was tightly coupled with that specific financial database. It worked okay when data stayed mostly within its original box, like you said, a collection of separate islands or ledgers. The control was really decentralized then, tied right to the system itself.
But then obviously there was this push to see the bigger picture, right? To see how all those islands actually connected. That must have been the first big leap towards making data, more consumable.
It really was. That's when data warehouses started popping up.
Yeah.
This is a pretty significant step because it meant actively merging certain data sets together into these central pools.
Right, central pools.
So instead of querying all these individual sources and getting a fragmented view, you could now query a blend of information all in one spot. The biggest thing they solved was giving that unified, sort of coherent view of different data. You went from individual ledger views to something like a comprehensive financial statement.
Makes sense.
But the new problem they introduced, security-wise, was suddenly having more data accessible in one place. That needed a whole new layer of access control thinking.
Right, creating those big centralized places. And then we took it a step further, didn't we? Especially with business intelligence becoming a bigger thing. You didn't just want the raw data. You wanted specific views, snapshots, reports, all tailored for particular insights.
Exactly. And that's where data marts came into the picture. These are more specific, organized subsets of information, often pulled from the data warehouse, but designed to generate particular reports or feed dashboards. So instead of a user having to wade through loads of raw data, they could just go to a dashboard and get a quick, targeted snapshot that was relevant to their actual job. It definitely streamlined access to specific insights, making data much more consumable for making decisions.
Okay, so that sets the scene for the traditional path. Data warehouses, data marts. But here's where it gets really interesting, maybe even a bit scary. How has this explosion of AI, especially generative AI and RE models, retrieval augmented generation, how has that changed this whole game? We're not just talking static dashboards now. We're talking AI systems trying to make sense of everything pretty much in real time.
That's the fundamental shift, yeah. With AI, especially Gen AI, using LLMs, large language models, you have this sophisticated system that helps users ask questions, then goes and gets the information and presents it in a really easy to digest way, often through an assistant interface.
Right.
And the critical piece here, technically speaking, is the role of vector databases. Information from all those traditional enterprise systems, finance, HR, operations, is being embedded into these vector databases.
Embedded.
Yeah, think of embeddings as like numerical representations of concepts or meanings. It allows the AI to query stuff contextually and really efficiently, find related information, and give you answers. And with our RAID models, it's even more direct. The AI can actually access and reference specific enterprise information to supplement its own responses, which helps make them more accurate and relevant to the business context.
Wow.
So the core problem, and this is really what we need to solve, is that in these AI scenarios, huge amounts of really diverse information are all getting merged into something like a vector database. And that raises the critical question: what privileges does the user talking to the AI have? And maybe even, what privileges does the AI system itself have?
Oh.
How do we control access in this new, merged, super dynamic data landscape? It's not just about one user accessing one database anymore. It's like having a conversation with an AI that's potentially drawing on everything your company knows
Hmm.
and maybe revealing connections you never intended anyone to see.
That is a truly complex puzzle, isn't it? When everything's mixed together to feed an AI, how do you even begin to put up the right fences? So, okay, let's dig into the strategies. You mentioned adapting an older concept first.
Right. So the first strategy is basically about reimagining access controls
Ugh.
specifically for this merged data.
Yeah.
The basic idea is this. When data gets merged into, say, a data warehouse or something similar, that merged thing itself becomes its own data asset. It's distinct.
A new asset. Okay.
Exactly. So access is then granted to this new asset rather than needing individual access to all the original source systems it came from. Someone, maybe a data steward, becomes responsible for understanding what users need from that warehouse and granting access based on that. It simplifies the request for the user they don't need to know about or ask for access to all the underlying bits.
Interesting.
But the sort of surprising implication is that this new asset needs its own security policy, totally separate from the policies of its original parts.
So instead of asking for access to finance and HR, you ask for access to the enterprise overview warehouse. That gives you a single point of control. Okay, I get that. But what about this idea of just granting all access if a user needs any piece of the merged data? That sounds risky.
Oh, it absolutely is. It's a potential nightmare, really.
Yeah.
The concept of all access basically means that if, say, an AI prompt needs info from lots of different sources within that merged set, the only way it gets the full picture is if the user, or maybe the AI system itself, has access to everything in there.
Yikes.
Or for dashboards, the thinking might be, well, if you want to see anything on the dashboard, you need access to all the original data behind it.
Yeah.
In practice, this is incredibly difficult and frankly just impractical for most companies. You're just not going to give everyone access to everything. It completely defeats the purpose of data security, especially the principle of least privilege. It's way too risky and goes against basic security rules.
So how do you get around that all or nothing problem?
Well, to mitigate that, what often happens is some clever data engineering. You restructure the merged data so that logical groupings of information can become their own sort of distinct data objects.
Data objects, like a specific report.
Exactly. Think of a specific report or maybe a particular view within a dashboard. That view itself becomes a data object that you can grant access to. This gives you more granular control than just the whole warehouse.
Okay.
But while that's useful, this concept is kind of difficult to apply directly to vector databases in the same way. Vector databases can hold millions, maybe billions of individual vectors, these numerical representations. It's really hard to think about managing access to each tiny vector as a distinct object like you would a whole dashboard view. You're generally thinking about logical groupings, not trying to secure every single tiny piece.
That makes sense. You group related stuff together even after merging to manage who sees what. So if all access is out and data objects have limits for vectors, what's strategy number 2? Something about avoiding constantly moving data around.
Yeah, that brings us to data virtualization. This is a fundamentally different approach compared to the traditional ETL process, extract, transform, load, where you're physically copying, changing, and loading data until it looks the way you want it somewhere else.
Right, the old pipeline approach.
With things like data lakes emerging, where you basically treat all your company data as this one vast, complete collection, rather than a pre-structured warehouse, data virtualization becomes really powerful.
How does it work?
Essentially, a data virtualization layer sits on top and creates a virtualized output. It's specific to what a particular user is allowed to see, and crucially, it does this at runtime, like right when they ask for the data.
Ah, so no pre-moving data.
Exactly. You're not constantly shifting data around. It's more like a dynamic filter or lens that provides a controlled view of the underlying data only when it's accessed. The big benefit is much, much better control over access, because the data is only presented in the permitted view at the exact moment it's requested.
That dynamic filtering sounds incredibly powerful for control. It's almost like having a bouncer at the door showing everyone their specific tailored view of the room. But for that bouncer to know who gets what view, they need a solid list, right? Something guiding them.
Precisely. You've hit the nail on the head. For data virtualization to actually work effectively, you need really strong data governance.
Hmm.
It's absolutely essential. You have to have a deep understanding of your data. What type is it? Is it PII, personally identifiable information like names, addresses, stuff that directly identifies someone?
Gotcha.
Or is it SPI, sensitive personal information, things like health records, financial details? You also need to know where the data came from, its lineage. Without proper classification and solid governance rules, trying to use virtualization to enforce the right access controls is, well, almost impossible. It's the foundation it all sits on.
Okay, governance is key. But you mentioned a catch earlier.
Yeah, there is a catch, especially for AI. While data virtualization is great for data lakes and general access control, it doesn't really play well with embeddings and vector databases in the AI world.
Why is that?
Because embeddings, those numerical representations we talked about, they're typically pre-generated. They're set up ahead of time, kind of baked into the vector database. You can't just easily apply a real-time filter to data that's already been mathematically transformed and stored like that. It's not like filtering a live data stream. It just doesn't fit the way vector databases work operationally.
Ah, okay, so that is a significant limitation when we're talking about AI pulling from these vector databases. If virtualization isn't the magic bullet for AI-driven data, what's the next strategy? The one that does work better with those real-time AI queries?
Given those limitations, the next strategy is what we can call intelligent filtering of AI results. This approach focuses directly on controlling the actual information that gets returned by AI queries, especially from vector databases or our RAG models. And there are basically two main ways to do it: pre-filtering and post-filtering.
Pre and post.
Okay. With pre-filtering, when a user sends a prompt to the AI, the results that are found and sent back are already filtered. They only include the information that specific user is authorized to see. The unauthorized data is just, well, it's never even presented.
So it's filtered before I even see it.
Exactly. Post-filtering, on the other hand, works a bit differently. The AI system first finds all the relevant results, like maybe finding all the nearest neighbors in a vector database based on the query's meaning. And then after it has that initial set, those results are filtered based on the user's permissions before they get displayed.
So one filters before delivery, the other filters the raw results after retrieval, but before showing me. Both sound like they'd work for keeping AI chats secure. But knowing how messy access controls can be, what's the catch? What do you need to make this filtering actually reliable?
The absolute prerequisite, the thing you cannot do without for either pre-filtering or post-filtering, is having a robust, comprehensive, up-to-date knowledge of your access controls across the entire enterprise. Yeah, you need to know precisely who is allowed to see what, whether those permissions are managed centrally or spread out across different systems. And let's be honest, that's a huge challenge in itself, just understanding that incredibly complex web of permissions in a large organization.
Definitely.
But despite that complexity, this strategy is highly effective for controlling what comes back from AI prompts. It ensures sensitive or unauthorized information just isn't revealed. It really hammers home how important it is to know your data and know who should see what constantly.
So yeah, it all circles back to knowing your access controls, which, like you said, is a massive task. Okay, let's shift to the next strategy. You mentioned something called birthright access. Sounds familiar, but maybe with a new twist for this merged data world.
Indeed. This brings us to birthright access. Now, it's not a brand new concept. It's been around in identity management for a while. But its powerful reapplication to merge data, especially in the context of AI, can simplify things quite a bit.
How so?
The core idea is that access isn't primarily about individual users constantly asking for specific permissions for specific things. Instead, it's about what access is automatically granted based on who the person is.
Based on identity.
Exactly.
Yeah.
It includes things like their organizational unit, what division or group they're in, their specific job role, maybe their physical location, and critically, what job they're trying to accomplish. It's kind of shifting from permission granted when you ask to permission granted because of who you are and what you do.
Okay, that sounds more efficient.
The beauty of birthright access is that it aims to drive data visibility based on identity and purpose. Users ideally don't have to go through a manual request process every single time they need a piece of information. Their identity, their defined role, automatically dictates what data they should be allowed to see. This massively simplifies the access problem, whether you're talking about getting insights from dashboards or retrieving data using AI in those RAG models. If the system knows who the user is and you have well-governed data classifications, you can merge that understanding to apply pre-filtering or post-filtering automatically, all driven by their birthright permissions.
That does sound like a really powerful way to scale security, especially with the sheer volume of data and users we're talking about now. It moves from being reactive, granting access case by case, to being proactive and identity-based.
Yeah.
That definitely changes how I think about securing AI. Before, I might have focused just on protecting the AI model itself, but it's becoming clearer that the real frontier is protecting the data it uses. But just like with data virtualization needing governance, I'm guessing birthright access leans heavily on something foundational too, doesn't it?
Absolutely. You anticipated it perfectly. This strategy, maybe more than any other we've discussed, relies heavily on strong, accurate data governance. If your data isn't properly classified, if roles aren't clearly defined with associated permissions, or if the access policies aren't meticulously managed and kept up to date, birthright access just kind of falls apart.
Right, garbage in, garbage out, security-wise.
Pretty much. But when it is implemented properly, with that strong governance backbone, it does simplify the problem of protecting merged data immensely. It provides a much more streamlined and scalable way to ensure users only access what their role and task require.
Okay, so we've covered these four quite distinct strategies. Reimagining access for the merged asset itself, using data virtualization for runtime views, intelligently filtering AI results, and using identity-driven birthright access. If we step back and look at the big picture, what's the common thread? What ties all these approaches together?
The overarching principle, the common goal uniting all these strategies, is least privilege. It's a cornerstone of security. A user or an application, or in our current context, an AI system, should only have access to the absolute minimum data they need to perform their specific authorized task, nothing more.
Just what's necessary.
Exactly. Whether you achieve that through creating a new data asset with its own controls or a virtualized view, or by filtering AI results, or through identity-driven access, the fundamental goal is to achieve this minimal, necessary level of access. It's all about precision in granting privileges to minimize potential exposure and risk.
Makes total sense.
And finally, there's a point that's just non-negotiable. It has to be part of any data protection effort, especially as these merged data environments get more and more complex, and that's compliance.
Compliance, always critical.
Always. You absolutely have to ensure that whatever you're doing is observable, meaning you have visibility, you can see exactly what's happening with your data and who's accessing what. And just as important is monitoring this data. You must track all the actions, all the activities, creating a clear audit trail.
So you can prove what happened.
Precisely. This shouldn't be an afterthought. It needs to be a standard process baked into how everyone involved manages data. Because without robust observability and monitoring, demonstrating compliance with regulations, with internal policies, it just becomes impossible. It's not just about setting up the security rules, it's about continuously proving you're actually following them.
It's really clear that as our world gets more AI-driven and data merging just keeps accelerating to fuel those AI innovations, these strategies aren't just, good practice anymore. They seem absolutely essential. The goal stays the same, ensuring the right access for the right task every single time. But looking ahead, as AI continues to evolve, maybe it becomes more autonomous in how it handles data. How might these strategies need to adapt even further to protect our most sensitive merged data? Something to think about.
It really is. The landscape is constantly shifting.
Definitely food for thought.
Yeah.
And we really encourage you, our listeners, to think about your own interactions with data, maybe at work or even personally, and how these ideas about protecting merged data might apply in your world. Your insights, your suggestions, they're incredibly valuable to this conversation. So please do share your thoughts and opinions down in the comments below. We'd love to hear them.
Yeah, absolutely.
Thank you so much for joining us on this deep dive into protecting merged data in the age of AI. If you found this discussion useful or insightful, please give us a like and consider subscribing to the channel. Make sure you hit that notification bell too, so you don't miss any of our future deep dives. And of course, please share this deep dive with colleagues, friends, anyone else who might benefit from thinking about these crucial insights. Until next time, keep exploring.